Okay, so I know I said we'd look at LaunchCode when we had time, but it's so much top of mind right now. I do want to show it real quick. Um, that's not gonna be happy with me. So there are something called esoteric programming languages. These are really made just for fun. Some people will use them for real stuff, but it's not how they're meant to be. Um, so yeah, like everything ends with K, thanks, bye. Um, I has a var. I'm in your loop. Up var. Yeah, this is how it all talks. This is the entire language. So there are other languages like this. I don't recommend this to be your second thing you learn unless you really want to. So cool. That's low code. All right. So we're talking about SQL today. This is the SQL sequel. Um, we will learn about one-to-many relationships. We will review joins and SQL queries. And then we'll also learn about subqueries, which is kind of a whole conversation itself. A few things that we really won't get into depth on are things like many-to-many relationships, and those are very useful. So that would be a great continuing learning thing outside of this. So graded assignment four, it's on a horizon. It's on the horizon, I guess. So in that assignment, you will set up a database. And there are several steps in which you will test your application using SQL commands. So just as a heads up, this is a great opportunity to start using your new SQL skills for that assignment. One-to-many. So what's one-to-many relationship? A real life example without thinking about syntax yet would be something like customers to orders. So if I'm a customer and I buy something, I'm this one customer and I can buy one order, or I can buy multiple orders. But an order can't have two customers. It's just going to be a one-to-many relationship. Also, you can think of like one product could be included in many orders. So this product right here, wild animals of the world, 50 postcards or whatever, a lot of people might have that in their shopping carts. But in the database, it's represented as probably just one thing. Another real life example would be one user on a social media site is going to be able to post. They're going to have whatever they post, it's going to be associated with just that. But they can post many posts. So it's another one-to-many relationship. Same thing as likes. You can't have two people being associated with the same like. Each individual like is associated with a person. So the page can have many likes. It's associated with one person. So here we have a table. It's a database table. It's about books. Um, this is not how we want to design things. This is bad design. And so, somewhat rhetorically, we have the question of okay, why is this bad design? I have a few like rhetorical questions thrown up there on the screen you can see, but I'll throw this out there to y'all. Any thoughts on why this is bad design? What makes this at least not great design? Any thoughts? Yes. Right. Okay. Yeah. So because we have all the authors and publishers in the same table, we can't. Yeah, it's a little bit more difficult to work with that data. I mean, it's easy to filter by the book titles or sort by the book titles and stuff like that, but it's a little bit wonky when we want to do custom stuff with the authors. Cool. Any other thoughts? No. Oh, yes. No. Ah, that's a really good point. Yes. So let's say hypothetically, we wanted to include the publisher's mailing address, their PO box. It'd be really weird to do that kind of an update on this table. You'd have to do something like select all of the publishers by their name, and then you know do something weird like that. Yes. Oh, for sure. Yeah, this could be the result of a query, and this would be fine for that. Yeah, but this wouldn't be how we'd want the data saved, like actually stored. Yeah, it's a good point. There'd be nothing wrong with getting this back as a query. So here's an example of better design. And so this is the idea of we're just going to take these other entities, the author, the publisher, we're going to give them their own tables. And so here we can see these one-to-many relationships show up, where we have one author to many books, we have one publisher to many books, and we have multiple one-to-many relationships happening here. A really useful thing to start thinking about is the best practices for creating models, for creating classes for application. Those are going to transfer very well to best practices for creating a table in a database. Right? So if you think about classes, we generally don't want to shove all the data of our entire application into one class. We want to break it out. And so what's cool, and this is what we will be learning really next week, or next class is when we start talking about it, is our classes in Java that we write. We're going to use things like Hibernate, and that is going to create a parallel table in the database that's like a one-to-one table for our class. And so here we have things like the book ID, the book title, and you can think of these as fields in a class. How to make a relationship work? Tough question, right? The relationships we saw are one-to-many relationships. For example, one author to many books. To make that relationship work, we need two things. We need a primary key and we need a foreign key. And so the primary key is something we're going to get for free. When we create a table, each line in that table, we're going to need to give it a primary key. That's how the database is going to know, which item it is. Keep everything unique. The foreign key is going to reference the other table's primary key. And so here in our book table, we have a reference of 1. And so that's associated with this John author. Another reference of 1, which is associated with John. Reference of 2, which is associated with Corey. Another reference of 2. And so you can see that this you get for free, but then this one you have to say we're pointing to this data, the other table. So another question, what SQL keyword could we use to output a combination of the book table and the author table? So if we have two separate tables and we want to just view them together, what SQL command could we use? Not going to give me the whole command, just the keyword that we'd be working with. Yes. Join, yes. Exactly. So we'd use a join, whether it's a left join or a right join or whatever join we choose, probably a left join. There I think we use them most of the time. So yeah, we could do something like join or select everything from table A and then join the data on table B where author ID equals author ID, something like that. And that would match them up together and we'd be able to print them out. So I threw together, before I do this, I threw together some SQL commands. We'll throw them into my SQL application, create a table, throw some data in there, and then we'll try joining tables and whatever else we want to do. Before we do this, though, any questions so far? Any questions on what we're covering? No questions. All right. Cool. So I'm going to back out of this. Oh, I forgot captions. Sorry, y'all. All right, so here I've got a database. I already created it. I called it class 14. And so I can really just copy everything. I don't need to copy things one at a time because I'll be able to run them however I want to. Okay, see if I can make this more visible. Does anyone know the zoom in for this? Yeah. Control and scroll. Yeah. Sweet. Thank you. All right. Sweet. Yeah, I'll have to go back to preferences later and get that set up a little more permanently. So the way I've been running SQL commands in MySQL is just selecting it, Control Enter, and I can see in my terminal, not quite a terminal, I don't know what you'd call this, but I can see that my action was successful, so that's good. I'm going to create this other table called books, Control Enter, and that just ran this block of SQL. Just a quick review of what we're doing. The table is called books. We have 3 columns, well, 4 columns. We have 4 columns or fields if you're thinking of a class. One's a book ID, then we set its type. It's a primary key. Those are important, and auto increments. We have a book title. It's essentially a string up to 100 characters long, and we're marking it as not null, cannot be null. We have an author ID, which is just an integer. And then we are taking the author ID, yeah, just 3 fields. We're taking the author ID and saying that it references the other table. So if I were to create these tables in reverse order, this would break on me. It would not be happy because I'm trying to reference the authors table in this command. So now that I have those, I'm going to add an author to the author table. 2 authors from the example. And I've written enough SQL at this point that I do want to verify that things are working. So I'll say select star for all, and then I will say authors. No, I need from authors, and I don't need anything else here. And so that's also kind of small. So what that gives me is it gives me a table with the 2 authors that we created. We saw in the example before. How could I, in my select statement, how could I just select the author name column? So looking at this select statement, how could I select just, I don't want the ID field, that's just clutter for me. How could I just select just the 1 column? Yes? Okay, let's try that. Sweet. Yeah, so that works very well. I can just, yeah, I can select just the author name, and then if I wanted to select more columns, I could do a comma, and then the next field I wanted to select. And so this can be very useful if we're using joins, like we'll try out a bit here. If we're using joins and we get like literally 100 columns of data back, that's a bit overwhelming, it's a bit hard to work with, and so we might want to select the specific columns that we want to see. Cool, so now let's go ahead and add a book. You'll notice, even though it's on 2 lines, people will format SQL on 1 line, they'll use multiple lines. However many lines you split it up by isn't so important. What it really looks for is that the semicolon. The semicolon is what ends the SQL statement. So I could really break this up quite a bit more, but I won't. So we're going to use the SQL keyword insert into, and then we need to say what table we're adding data to. So we're going to say books. Then now we're going to need to reference the columns that we're inputting data into. So we're going to add data to book title in the author ID column. And then the values we put into there, if you're thinking about functions, you could think of this as an argument and this as a parameter, almost. And so we're going to pass in a philosophy of software design to the book title, and then the author ID we have to know its associated author ID. And so here we kind of already know. So we're going to say uh, ID is 1, which is going to correspond to John. So run this. Then now let's go ahead and look at our books table. So here we can see that we now have the book ID is 1 that was auto-generated by SQL. And then we have a book title, which is the one we gave it, and then the author ID is author ID 1. And so we can see what the author is now if we do a join. So let's go ahead and try to do a join. So for a join, we will start with select all from books. And then I think it's left join, and then we will say the name of the table, which is authors. I believe it is on, it's either on or where, we'll find out. Books dot author ID equals authors dot ID. Is that what I named it on both of them? Yeah. Let's see if this works. And it does. So here we can see we have successfully selected all of the rows from both tables on both books and authors. And we are joining the tables together where the author ID from the books table is the same as the author ID from the author table. And so the difference between, this will be a fun question. What's going to happen if I change this to write join and I run the command? Any guesses as to what will happen? We can find out. No guesses. That's cool. It does the same thing almost. So here we just reversed the order in which we're doing things. So now we still get this first row, but with a right join, we're taking all of the data on the right table, which is the authors table, and only the matching data on table A, which is the books table. And so because of that, because we select all of the author data and then only the matching book data, we get something that looks like this, where we get all the authors and then we just get the book for it where it matches up. So if I just do a left join, I don't get the other authors because I'm saying I want to select all of the data on the book table and then only the authors that match up with my table. Cool. So thoughts or questions on that whole join process? Joins what we're looking at here. No? All right. Let's go ahead and finish this up. We will run the command to add another book, another book, another book. Then we can go ahead and see what this looks like again. So run this again. At this point, left join and right join don't matter. They're not going to make a difference because the data is going to be the same either way. Because there's not a case in which we have an author that's not associated with the book. So that it's always going to select all of them. Cool. Other relationships. We have many-to-many relationships. These are really important. You definitely will see these in the wild when you're coding projects out. A great example of a many-to-many relationship would be something like products to customers. So one product could be associated with many customers. Many customers could be associated with one product. I think a better example is product to categories. So if you think about like a movie category, like I don't know, like animated, like think like a Pixar animated movies. A lot of movies fall under the animated category, and then the animated category has a long list of movies into it. So a movie could potentially have an animated category, and it could also have like uh, another category too, like musical. And so the movie has many categories. It has musical, it has animated, it's cartoon, all these different things you want to throw at that. But then each category itself has many movies associated with it. And so this is a normal thing that we're going to see with data, but then we have a question like, how are we going to make this work in SQL? Because the way we do one to many, it's not going to work. It's not going to work for a many to many relationship. So, in order to do a many to many relationship in SQL, we need a third table. So this table in the middle is going to sort of act as like the mediator. And it's basically saying, well, let me outline this for us. So we have two tables. We have a product table, and then we have a category table. And so a product may have many categories, distinct categories, and a category may be associated with many distinct products. And so we have a third table right here with a product ID and a category ID. The product ID here, you'll see, we have laptop represented as 1, and it's represented over here as the electronics category. Over here, we have an example for smartphone. Smartphone is part of the electronics category. It's also part of the accessories category. We can see with camera as part of the electronics category. It's also part of the photography category. And so that's how many to many relationships look in a database. We have 3 tables. We've got the 2 tables with the data, and then we have a third table that documents all of the relationships. We also have something called a one-to-one relationship. These are, this is essentially, you just had a table and you split it in half. You can turn that into a one-to-one relationship. There's not a ton of use cases for this. Maybe there's more than I'm thinking of. But one example that we have here is maybe you have a table full of your usernames and passwords. And then maybe you have another table that is your users. And so like their bio, their username, things like that. So if we're doing something like that type of association, that makes sense because we want to kind of keep the passwords and stuff separate from everything else. Cool. Random question. I tend to think about security, and I know it's not a huge emphasis in the curriculum because that stuff comes later. But can someone tell me what is a flaw in this table right here? Yes. Plain text, right. So we saw, like, when Anonymous had us hack the bank. We got passwords, and they were plain text passwords, which meant we were able to use them. A best practice is never, ever, ever, ever to store passwords as plain text. Instead, there are various methods to encrypt them and store them in your database encrypted. And then essentially it's something like this, where the username and password, they go through a process, a one-way process that encrypts them. There's not a way to decrypt it. The only way to produce the same encrypted string is to type in the username and password again, and it goes through the process and it creates the same gibberish encrypted string. And so not even the owners of the database could log in as you unless they knew your actual password, barring a lot of other things that could go wrong. But essentially, when we're just talking about SQL, in the future, when you start building the internet of the future and all the different things you may build, just know that that's something that should never be done. Queries and joins. This is a light review. So we know about selects. They retrieve data. Insert into, it adds data to the table. So we will say the insert into command, the name of the table, and then the names of the columns that we're adding data to. you'll notice that earlier in the previous example, we did not include the primary key, the ID. The reason why we didn't include the ID is because it was auto-generated. And so we just included the columns that we needed. Then we have values. Then we include just the values we needed. Update. This is if you need to modify a line of code, not a line of code, a line of data in the table. We can delete data from the table. And then the where command. This is very useful. Essentially, the where command is a lot like an if statement. That's how I like to think about it. And so what where is saying is it's basically saying only do whatever stuff came before the where command. Only do all that fancy stuff where this condition returns true. So for example, you could say only delete the user from the database where their ID equals number 1700 or whatever. Then you delete user number 1700. So the where condition is very useful. So here's an example of a regular select statement. You just get all of the books. And then if we wanted to get just one book, we say select all of the books. We'll select all of the book titles from the book table where the author ID equals 1. And so that actually won't get just one book if there's more than one author, but I think you get the gist. We talked about SQL joins earlier a bit. Here's just sort of a review. So here is an example of a left join. Now you've heard me say a couple times that left join is kind of the 80% rule. It's like what we're doing most of the time. The reason why I think that is because what a left join is essentially doing is it's saying, hey, take this table I'm starting with, and then we're going to get data related to this table I'm looking at. A right join is the same thing as a left join if you just swapped the order of your commands. So for example, if I take table A and I change this to table B, and I take table B and I change this to table A, that's the same thing as if I made this a right join. So why is it useful to know that right join exists? It might be useful to just quickly change left to right, but it's not really giving us some revolutionary new ability. So typically, as a developer, imagine most of you using left joins. And then the other types of joins that you might see are selecting just everything. So selecting everything from table A and table B, which I think there was a reference slide last class about that, the different types of joins you might do. But if you had to know one, this would be the one to know. So quick pause for questions. Questions on joins, SQL commands, all those different things that we covered. All right. Subqueries. What is a subquery? So essentially a subquery, it is a query within a query. And this is where, in my opinion, SQL gets a little bit more advanced. We have just a normal query here. At least it starts off that way. So select everything from the customer table where the customer ID exists in ... Then we have another query. So to break this particular example down, this is the same line of SQL, it's just broken down by line. So we're going to select, I believe it is, yeah. Select all of the customers from the customer table where, it's like a but, only if this is true. Only select the customers if the customer ID exists in this table. And so we select all of the customer IDs from the orders table. So, question, what types of customers will this query give us? Yes. Customers that have ordered something? Yes, exactly. So this will give us all of the customers that exist in the orders table. So this will just tell us all the customers that may have ordered something. And that's the types of questions you might find yourself answering if you go down the subquery route. is you'll be answering questions like that, right? We want all the customers, but only the customers that made an order. So you might be asking yourself, what's really the practical difference, at least in this example, of using a subquery versus using a join? Personally, if I was doing this, my brain would lean towards join because I understand joins. I've used joins. I haven't used subqueries as often. Um, they're essentially doing the same thing. Now, this one I might need to think about for a little bit here. What's going to be the difference between this subquery SQL, what it outputs, versus this join and what it outputs? How could their outputs be different? And so I'll review this real quick while we're thinking about it. So we're going to select all the customers, but only the customers that are found in the order table. In this case, we're going to select all the customers and we're going to associate the orders with the customers. Yes. Right. Yeah. So you're on the right thought process. This is going to give us this join is going to give us all of the customers, even the ones that didn't place an order. Yes. I thought a simple join would say that. A simple join? Oh, yeah. I was thinking left join. I think you're right. Yeah. Sorry. So let me back up. If this was a left join, we would have all of the customers from table A and all the customers from table B. Sorry, I set that up wrong. And all the customers on table A from the customers table, and then all the orders that are associated with it. Because this is a simple join, which you pointed out, we're only going to, this is essentially going to be the same thing. Yeah. So last little bit here, this is the other section. Here I just want to throw in an example on how to take data from one table and shove it into the other table. So here we have a insert into. This is same as the insert intos that we've seen before. And then we can select, for example, the columns we're adding the data to. And then we can select our other table. And we can essentially say what columns we're selecting from our other table. We could hard code some of the data if we needed to. We could do it for multiple tables. And then essentially everything from this line is going to be added to this line right here. Cool. So I think we're pretty early here, pretty early, close to studio review. Any questions? Anything else you wanted to explore while we're still here? Yes. Right, that's a good question. So if we look at this slide right here, number right here is associated with the house number. Street is associated with street. City name is associated with the city. The state here is a string. It's hard coded. And in this example, the reason why we hard coded it is we're basically taking all of the addresses from the Missouri addresses table and putting it into our general addresses table. And so we just hard coded that it's from Missouri. Yeah. Excuse me. Cool. Other questions? Yes.
This is kind of maybe a higher level question. So when we downloaded MySQL, we downloaded the workbench, then we downloaded the database, and then create the schemas. How does that all relate to each other? How does what are we doing with the database? What are we doing with the workbench? And how does what do we need the database? We have multiple databases, but the workbench. Can we separate out the schemas, two different databases? And what's the relation to the schema of the database and the workbench?
Right. So the workbench is best to be thought of as like an IDE. So workbench is to SQL as IntelliJ is to Java. As far as the actual database tables, in my brain, and I'm mean, I'm probably oversimplifying them. I just think of them as Excel workbooks because an Excel workbook has multiple tables within it, and all those tables have columns and rows. Um, and so typically, most applications are only going to have one database they interact with. I'm sure there's exceptions. And so from there, you'll have like many tables in the application. I don't know if I've quite talked to your question exactly. Um, is that helpful, or am I going in the right direction with it?
So, like, I mean, when we dive into like the workbench, you have select like the 3300. Like, why? Like, what is it?
Oh, 3300. What is that? That is a port. So once if our database is up and running, uh, we can access it through HTTP. Similarly to how you would access a website through HTTP. Um, and so when we wire this up to our Java application, we're going to need to configure it in our private.properties file and say like, hey, this database is running at this port. And if you had multiple databases running, they'd be on multiple different ports. But we're probably just going to be worried about one database. That's the normal case. And then from there, you'll need database credentials, which in the real world are one of the most sensitive things you have as a developer is database credentials, if you have them. So you want to protect those. And so, yeah, so the port 3000 or whatever number it is for the database, that's assuming that it's running. That's how your application is going to talk to it.
Is that always running, or do like we start up workbench, start it up?
Um, it's not always running. So Workbench is probably doing something to get your database up and running. It is not the only way to start up a database. So hypothetically, you could start up a database through a terminal, and there's a lot of different approaches to that. MySQL Workbench is doing that for us, and it's starting it up, and then we can access it. So like for example, if we're using something like Docker, which we haven't talked about Docker, it's outside of the scope of this class. But we could basically put a database inside of a Docker container and run a command that says Docker container name start, something like that. And then that Dockerized database is up and running, and it is at a port, and our application can talk to it. Now, hypothetically, let's say we put our application in another Docker container. And so when we spin it up, we say Docker start or whatever, the application is running. We can then take those two things and put those on a server, or a more sophisticated setup than that, if need be. And so the future of kind of working with databases and stuff like that is, and an application is, your application is going to be running on something like a computer in the cloud, something like a server, and your database is going to be available in the cloud, and it's going to be available at an address, at a port, using credentials. Yeah. Hopefully that's helpful. Other follow-ups to that, possibly. Okay. Well, I think we will, in that case, go ahead and break for studio early, and then I'll see y'all here at 8, and we'll do studio review. Thank you.